All right, guys. So one thing that I'm adding for you guys is something called the concept of polarity. So underneath covalent bonds, you have two types of bonds that you can essentially have. You have nonpolar covalent bonds, and you have polar covalent bonds. And we started to talk about this a little bit on the Zoom today, or I guess it was yesterday. But basically, the idea behind a polar bond is something like this. Imagine I am in a tug of war. Okay, so draw me. There's me. Yay. Okay, I'm in a tug of war with LeBron James. So LeBron James is over here, and he is a lot taller than me. Oh, that's terrible. It's okay. But anyways, we are in a tug of war. He is going to be winning that tug of war because he has a lot more strength than I do. So I'm going to make my person a little bit sad. I'm going to lose probably. So I'm losing my tug of war. I'm still in the tug of war because, whatever. I'm still in it. But the flag is going to be a little bit more on LeBron James's side. The same thing happens when you're sharing electrons. So different atoms have different sizes based on what element it is. And based on the size and strength, essentially, and we call this specific kind of strength, we call it electronegativity. Okay? It's basically the strength to pull electrons to yourself. And every single element has a different electronegativity. So for example, here, this actually shows how electronegative these different elements are. It's a periodic table, but now it shows if they're super strong or if they're not so much. So for example, fluorine is going to be super, super strong. Now notice your noble gases don't really have any kind of electronegativity because they don't want electrons. They're not going to engage in the tug of war at all, so we can just take those out of the equation. But fluorine has a really, really, really high electronegativity. So most of the time, it's going to win that tug of war. Now, the cool thing that happens when you have polar bonds, okay? So because polar bonds means not equal sharing, that's what's happening here. You find polar bonds exist when you take something that has a really, really big difference between the two. So let's actually make a water molecule really quickly. So water is made up of oxygen, which has an electronegativity of 3.5. That's fairly strong. And then hydrogen, which is over here, and that has an electronegativity of, let me move this over just a little bit, 2.1, okay? So even though they're going to form this covalent bond, we know from making our diagrams that you're going to get something like this when you make water. However, these bonds right here between the hydrogen and the oxygen, they're actually not going to be completely equally shared between those two atoms. Instead, most of the time, the oxygen is going to have the electrons a little bit more on its side. So what this looks like in terms of a model goes, water molecules actually kind of look like upside down Mickey Mouses. So you have your big oxygen and you have your hydrogens. So oxygen, because it's winning that tug of war and electrons are negative, it's going to have a small negative charge. Now keep in mind, this is not an ion. It's not as big of a charge as an ion. It's a partial charge. So that means the hydrogen has a partial positive charge because, again, that electron is a little bit more, the flag is a little bit further on the oxygen side. So the thing that makes polar bonds so cool is the fact that when you have a lot of these together, you get something like this, okay? So I have my oxygen, I have my hydrogen happening here. Now, the same thing happens in all these different molecules, so you can form these little connections because positive and a negative attract, right? So positive and negative attract, and you get something that causes a lot of different things in nature. So it'll cause things like surface tension. It causes water molecules to move further up a plant. It's the reason why if you take a penny and you drop water droplet by water droplet, you'll form like a bubble before it bursts, right? these bonds right here are what is keeping those molecules together and what makes water such an essential thing, essential molecule for life, essential compound for life.